examples about derivatives that will make it easier for us to compute the derivative of any function. Okay, let's start with the first and easiest one, the constant rule. So basically, the idea of this derivative rule is that the derivative of any number or constant is just equal to 0. If you have the derivative of pi or e or 2 or 1000, everything is just equal to 0. And this is because like any number as a function would just give us a straight line, a horizontal line with no slope. So that just gives us the derivative or slope of 0. Let's go to the second one. So the power rule. So this one is a little more useful and it's really cool. So when we're trying to compute the derivative of powers, you can use the limit definition and you have to do like x plus delta x to whatever power this is. So we'll just say to the nth power minus x to the n over dx. And this, if you get bigger and bigger and bigger n's, it is really hard to compute. So this power rule is really, really useful. So the idea is if you have x squared, you have to do x squared plus 2x delta x plus delta x squared. And then that over x delta x, this would cancel out. And because you're subtracting minus that thing, this would cancel out. This would be equal to 0, so you would just get 2x. And then x cubed, it would just be the binomial theorem, this thingy. 3x delta x squared plus delta x cubed. This would cancel out. This would be 0. This would just get to 1, but this would be 0. This would get canceled out, and you would just be left with that. And so on and so forth until like x to the nth power, right? You would get x to the n plus nx to the n minus 1 times delta x plus, and so on and so forth until you get to delta x to the nth power. And this would always be equal to 0. This would get canceled out. This would get to just that. And everything else would have delta x in it. So those would also be equal to 0. And all you would be left with is nx to the n minus 1. So that means that the derivative of, okay, let me just scroll down a little bit. So the derivative of x to the nth power is just equal to nx to the n minus 1. That is the power rule. It's so useful. But to use it a lot, you just need to know one more rule called the sum rule. Sum and difference rule. Okay, so basically, the derivative of f of x plus or minus g of x, so this is sum and the difference, is equal to f prime of x plus or minus g prime of x. So if you're adding the functions, it's the adding the derivatives, and subtracting them, you subtract. So f prime means the derivative, basically. So yeah, you can compute the derivative of like say 3x squared plus 2x. It would just be equal to 6x because of the power rule plus 2. If it were 3x squared minus 2x, it would be 6x minus 2. Let's go on to the next rule, a constant multiple rule. So we'll just call this the constant CMR. So the derivative of c times f of x is equal to c times f prime of x. The constant is not changed. So if you had the power rule cx to the nth, you get ncx to the n minus 1 would be the derivative of that. The constant in front of it never gets changed. So that is the rule, basically. So these are a few of the more really simple rules which you can memorize really easily, and this will help you so much in computing derivatives. One more last thing before we end the video. This is a really short one. This is just the rules. Is the trig limits. I mean the trig derivatives. So the derivative of sine and cosine. We'll talk about the other four in the next video. So this is equal to cosine x, and if it was cosine x, it would be equal to negative sine x. You just need to know this, and you can observe this when you're looking at a graph. Sine of x is equal to 0. It looks like that, right? And on this side, it looks like that. So at this, it looks like it's at 1, and then here it's at 0, and here it's at negative, and that's equal to negative 1 here, and this is equal to 0. So this just corresponds with cosine. But here, it is just the opposite. It's going to be the derivative of that is going to be negative sine. So basically, that is the trig derivatives. We'll see how we can compute the other four derivatives using other rules, which we'll be discussing in the next video. Until then, thank you for watching and peace out.